what's going on, guys? In my previous video I talked about semiconductors, especially about p-type and n-type semiconductors. In this video we are going to see what's going to happen when we combine these two together, when we combine this p-type and n-type together. When we combine these two together, what's going to happen is we are going to create something called p-n junction. p-n junction. As the p-n junction created, what's going to happen is this extra electron in this n-type semiconductors will tend to move and fill up these holes right here. As it moves from right to left, what's going to happen is the left side of this p-n junction is going to be negative, and the right side of the p-n junction is going to be positive. Now let's see why the charges behave the way they are. In order to look at that one, we have to look at something called formal charge. Formal charge is given by valence electron minus bonds plus dots. Now let's look at for this phosphorus. This phosphorus has 5 valence electrons minus we have 4 bonds and a dot. So 5 minus 5, that's going to be 0. So here it's going to be neutral. And for this one, aluminum has 3 valence electron. Aluminum has 3 valence electron and 3 bonds. This is a hole, this is not a dot. The dot is from silicon. So 3 minus 3, that's and 0 dots, right? 3 plus 0. So we are going to have 0 right here. So it's also going to be neutral. Now after this, it loses, like when P loses 1 electron, let's see what's going to happen. Let's get rid of this part. Okay, after that 1 electron moved to the aluminum, aluminum is going to have a structure like this. It's going to have aluminum, silicon, silicon, silicon. Now let's go ahead and calculate the formal charge. Formal charge is valence electron, that is 3 minus bond plus dot. Here we have 4 bonds, 0 dots. From this one you can see this is going to be negative charge, negative 1. So that's going to be the charge right now. Now let's look at for phosphorus. After it loses the 1 electron, it's going to have the structure like this. Si, 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 and this is going to be the formal charge is going to be initially, like we had 5 valence electron for phosphorus, and here we have 4 bonds and 0 dots. So this is going to be positive charge, positive 1. So this is going to be a positive charge. And that's all about this one. Now let's see what happens to the p-n junction. Now let's get rid of this one. So as we discussed before, okay, this is our p-n junction. So when we have holes in the p-type and n-type has electrons, so electrons will always tend to move and fill up these holes. Fill up these holes. So as it moves this side, here we are going to have negative charge in this side, and in this side we are going to have a positive charge. So when this happens, what's going to happen is it will create like an electric field will be generated across the p-n junction, and the new electrons, it's going to be difficult for them to cross the p-n junction, and those electrons on the right, they still want to fill these holes. So they still feel a force that wants to accelerate them toward the left. However, they are repelled by the negative charge, and so then these two forces reach a state of equilibrium. Then electrons no longer cross the p-n junction, and so this is going to lead to a constant junction potential, and this is the basis for the formation of a diode. A diode is an electronic device that conducts electricity in one direction and doesn't conduct electricity in both directions. So if you were connect this across the battery, and if you don't connect it in the right way, there are going to be no current. If you connect it in the right way, there will be a current flow. So that's all about this tutorial. I hope this helps. Thanks for watching.